In this section, we're going to take a look at hyperparameters and hyperparameter tuning. We'll start off by talking about hyperparameters and what they actually are. And then we'll look at a couple of different hyperparameter tuning methods, grid search and then random search. And then finally, we're going to do kind of a fun mini project at the end focusing on music synthesis, which is going to use sequence modeling in order to generate songs. In this video, we'll introduce the concept of hyperparameters. So we'll take a look at a few different things. First of all, we'll ask what are hyperparameters? And then we'll look at scaling different numerical hyperparameters and get a sense of the topology as a hyperparameter, meaning the network itself. And then finally, we'll explain this strange analogy that people use when they describe different methods of learning when they talk about pandas and caviar. So fundamentally, a hyperparameter is any parameter in your model that's not directly learned by your optimizer. Now remember, the optimizer, whether you're using stochastic gradient descent or RMS prop or atom, is actually updating the learnable parameters inside of each one of the layers of your models, so floating point numbers. So hyperparameters end up being things other than those learned values. For example, the learning rate itself, the choice of learning algorithm, values that you might place in for momentum, or the most interesting hyperparameter of all, the data that you choose to work with. Because dividing up and having larger and smaller sets of data can have wildly different influences on your machine learning algorithm. And the topology. So the network shape, the number of layers, the choice of convolution, the choice of dense, the choice of recurrent, normalization, batch normalization, any one of these values isn't learned by the optimizer itself. It's a value that you decide and you need to search through and iterate in order to find the best model to fit your data. So one thing to keep in mind when we're talking about updating hyperparameters is there are actually no hard rules as to what works. You need to be thoughtful about your parameter values and fit them in range. For example, if you're learning a floating point value having a scale of 0 to 1, you need to have learning rates and parameter values that actually match up against that. And if you're actually looking at learning the number of layers in your network, you need to actually have enough layers in your network in order to generate an output. So for example, if you have 10 different classes that you're learning, if an intermediate layer of your network squishes that down to, say, 4 hidden units, you don't have much chance of learning 10 different outputs if you've condensed your network to merely have 4 layers. It's just not enough information to pass along. So you have to have some global sense as to what you're optimizing for and a bit of a feel for the numbers themselves in order to pick the hyperparameter values. So how does one go about hyperparameter tuning? Well, there's really just 3 steps. In the first step, you actually decide which hyperparameters you're interested in tuning. And then you pick the set of hyperparameter values in order to validate your idea. And then you train your model with. And so you repeat this over and over and over until you find a set of specific hyperparameters that tune in order to train your model to get to the best result that you can get. Now this can actually be very time consuming, particularly if you go about manually picking the parameter values or manually picking the values that you're working with. So there are a couple of different ways of thinking about learning, and this will bring us to the concept of pandas and caviar. And the analogy is a bit of a weird one, but it's actually kind of cute. So if you think about a panda with its cute little tiny panda cub, each specific panda cub is raised and loved by its panda parents. And that is analogous to when you lovingly hand tune your hyperparameters or lovingly create your individual layers in your network, and you personally invest a huge amount of time in the hyperparameters and the topology and the data of your machine learning model. Compare that to caviar, where you have the big fish laying a huge number of eggs and they lay them and move on, and there's really no care or nurturing at all. It's parallelism. You have a very large number of possible different tests and you see which one works out, much more a survival of the fittest kind of methodology. So pandas is when you put your time and energy and thought in, and caviar is when you have the computer put the time and energy and thought in by working in a massively parallel fashion, try a bunch of different ideas, and simply seeing what works out.